Okay, so second point is that whenever we are doing DC analysis, we have to short circuit all the AC voltage sources. And similarly, if it is a AC analysis, we have to short circuit all DC voltage sources. So here, if I short circuit this, so then there is no current, the current flowing will be only an RS. But as we are open circuiting this capacitor, there will be no current flowing through this path. So by default, if I short circuit or keep it as it is, this whole path will go off. There will be no path here, and similarly there will be nothing at the output also. So what you will be getting after DC, these 2 points, what you will be getting, that will be the only this much circuit, and that circuit I had drawn it here down. So which is having RD, RS and RG. These are the only 3 things which will be present now. So now we'll see the DC analysis. What do you mean by looking at DC analysis? That means we are going to find out for this circuit how much is ID, how much is a drain to source voltage, and how much is a gate to source voltage. So we don't know what are the values of RS, RD and VDD and also RG. We don't know what are these values, but by finding out the values or finding out the equations, we'll come to know if I want to have ID, what all the components are responsible for keeping ID to some quantity or to some values. So that means I need to have an equation of ID which will have some values of RD, VDD, RS, VGS, all these things will be present. If I want to have VDS some value, then what all the components are responsible to keep some value of VDS. So all these things I'll come to know only after analyzing, and that analyzing will be doing it now. So that is called as DC analyzing. So to have this DC analyzing, we'll take 2 loops. One is the loop at the input through this path. So if I want to take the loop through this path, then what all the components are coming, we'll see that. And second loop I'll be taking, that will be VDD and this output path. So first we'll see the input loop. So in this input loop, if I want to write the input loop, how will I write that? I'll write in this fashion. So plus minus Ig into Rg. I'll call this voltage as Vg. So Vg voltage, plus to minus, I have taken it as a positive. Secondly, Vgs is plus minus. So I'll take Vgs as minus Vgs. That is the voltage between gate to source. We are taking KVL, remember. Third thing is Vs voltage, which is from source to the ground. So I'll write that to also as minus Vs, because the current flowing in this path will be ID current, because the current entering in FET is ID. So leaving the FET will be also ID, because Ig is equal to 0. And I have taken all these 3, then I'll write this as equal to 0. Okay, Vg voltage across Rg, Vgs voltage between gate to source, and Vs voltage from source terminal to ground. So three components we are taken in this KVL path. Now according to our concept, what we said, there is no Ig current in JFET. Ideally there is no Ig current, because this is always a reverse biased. So that's why Vg will be equal to Ig current into Rg, but as Ig is equal to 0, our Vg will be equal to 0. So according to that concept, this Vg is now equal to 0. Now remaining only these 2 components, which are Vgs and Vs. So Vs, if I want to write Vs, how will I write Vs? Vs will be equal to Id into Rs. So putting that value Id into Rs in this equation, we'll be getting minus Vgs minus Id into Rs equal to 0. So this is what the equation we have got. So again, simplifying this equation in the form, Id is equal to minus 1 upon Rs into Vgs. What we have done? we have equated it. Taking IDRS on this side and dividing by RS, I will be getting minus 1 upon RS into VGS is equal to ID, and we are written in this form. So remember this one equation, equation number 1. I'll call that as a equation number 1. Now second, we'll be taking the other loop. Now the other loop is this loop. So in this loop, we'll take all the components starting from VDD directly. So these components are VDD. I'll show you the circuit also. From this circuit you will understand what all the components we have taken. Okay, so from this circuit you can see that. So VDD is the voltage here. VDD, this is the voltage. VDD, I taken it as plus, so that will be minus to plus. So if your concept confused with VDD, I'll show that VDD in this fashion also. It doesn't make any difference what it is. Plus here and minus to the ground. So this will be now the complete loop. You will understand the loop now. Okay, so this is the complete loop. Plus minus VDD. So I'll rub this, and now it is, you can look at VDD. So taking minus to plus as positive, minus to plus as positive VDD, then plus minus, because ID current is flowing towards the drain terminal. So now the voltage drop across RD will be plus minus. So I minus of ID into RD. Have you understood that? Third component is VDS. Again, VDS is always shown as the voltage between drain and source. So plus and minus, plus here, minus here, and that is VDS. So minus VDS. Fourth component is the voltage across VS, which is source terminal and ground. We had already taken that, which is equal to ID into RS, and that too again minus sign, because positive at the top, ID is flowing from top to bottom, so positive here, negative here. So minus ID into RS is equal to 0. This is the complete equation for output part. Have you got this equation? So I'll simplify that equation again. So instead of taking this as second, I'll simplify that equation, saying that VDD is equal to ID, taking into bracket RD plus RS plus VDS. So from the above equation, just simplifying it, VDD is equal to ID into bracket RD plus RS plus VDS. This is what the equation I have got. Again, I'll simplify that equation and make it in some different form, and that different form I'll write it here. Okay, so that different form which we had got, what was that? VDD is equal to ID into bracket RD plus RS plus VDS. This is what the equation we have got here. I had shown you VDD after taking all this minus on the other side, which will be equal to ID into bracket RD plus RS, because here also RD is there, here also ID is there, here also ID is there. So taking ID common and taking into bracket RD plus RS plus VDS, taking on the other side, that has become positive. So the same equation I have written it here. Okay, so again I'll simplify that. How I'm going to simplify and what I'm going to do with that, I'll show you. Now you don't require the path. Now you have understood the path. So taking here ID on this side into bracket RD plus RS is equal to VDD minus VDS. Just I have done is that VDS from this point, this side I have taken on the left hand side, so that's why it has become negative. Okay, have you understood this? Okay, so now dividing by RD plus RS on both the sides, so I'll be having ID is equal to minus 1 upon RD plus RS into VDS plus 1 upon RD plus RS into VDD. Have you understood? Just I have divided by RD plus RS on both the sides, dividing here I have got it 1 upon RD plus RS. Dividing here I have got 1 upon RD plus RS. Now minus sign of minus VDS is still there, plus sign of VDD is still there. Okay, so this is the second equation. I call this as a second equation, and we had also got the first equation. This is the second equation. So okay, so first equation we have got, which says, this was our first equation, which says ID is equal to minus 1 upon RS into VGS, and second equation is ID is equal to minus 1 upon RD plus RS into VDS plus 1 upon RD plus RS into VDD. So these are the two equations. Now I will come to some coordinate rules, how they are used and why they are used. So if you remember the line equation which says y is equal to mx plus c, and second line equation says y is equal to mx only. So this is a equation of a straight line, y is equal to mx plus c and y is equal to mx. So if I want to plot this two, then it will be somewhat like this. Let us take x coordinate and y coordinate. So these are the two coordinates. If I want to plot this y is equal to mx plus c and taking m as a positive, then what you will be getting, if x is equal to 0, then what is y equal to? Y is equal to c, and that is positive. So somewhere here is the point. Let us say this is a c point. Okay, and what if y is equal to 0? If y is equal to 0, if y is equal to 0, then x is equal to, what will be x equal to that time? It will be minus c upon m. So that means that value or that point will be somewhere here in the negative side. Okay, so the straight line, plotting that line, this line will be like this. If m is positive, remember m is always a slope and c is the cutting of y line or y axis when x is equal to 0. This is a straight line equation, y is equal to mx plus c. Secondly, what will be the equation here? So if x is equal to 0, y is equal to 0, and if y is equal to 0, x is equal to 0. That means this line is again a straight line but passing through origin. This is our origin, which is 0, 0. So the line having the same slope will be like this now. So this is y is equal to mx, this is the line, and this line is this line, which is y is equal to mx plus c. And this are only provided your m is positive. Positive, that means the angle made to the x-axis will be greater than 90 degree. And if what will be the similar way, what will if m is negative? So again I'll show that too. If m is negative, then what? So again y-axis and x-axis. Let us assume m is negative. If m is negative in both the cases, in first case y is equal to negative. Again, if x is equal to 0, y is equal to c. Again a positive quantity, somewhere c. Again, just like previously also we are plotting that c here. Okay. Now as m is negative, remember, putting y is equal to 0, what will be our equation? That will be m divided by c. X will be equal to m divided by c. That will be a positive quantity. Why? Because m was negative, taking that m on this side will become positive, so that will be m divided by c. So it comes in the first quadrant somewhere here now, which is m divided by c. Similarly here it was minus m divided by c. Both the points are similar. Now joining these two points and making a line. So this is our line equation, which for what? For this one provided minus m. Okay, so maybe my line is not as straight as it should be, but somewhat like this your line will be. And similarly, if taking for the second this coordinates y is equal to mx, if I put y is equal to 0, x is equal to 0. If I put x is equal to 0, y is equal to 0. Again, this is a similar line. The only thing is that the slope being the negative, I will be having this type of graph, okay, which is again passing through the origin. When m is negative, that means your slope is negative, and slope is negative, I will be having a line which will be making less than 90-degree angle to the x-axis. Okay, so have you understood this concept? So coming back to our two equations, first equation and second equation, and also coming back to the this is our first equation and this is our second equation, and coming back to the graphs, two graphs we had plotted, and those two graphs were these were the two graphs. This is one graph which was between ID and VDS, and this is our second graph which was between ID and VGS. So taking these two graphs and these two equations, let us take this first graph which says on y-axis we are having ID, on x-axis we are having VDS. Taking the second equation which says ID is on y-axis, and this is what we are having, ID on y-axis, and VDS on x-axis. This is what VDS I am having on the x-axis. So this is again xy coordinate, and the line made by this equation which is having negative m, getting this, m is negative, that means according to our concept just now what we had seen by the coordinates, for negative m, this is what the line equations you are getting. This line equation is when y is equal to mx plus c, and this line equation, this line is because of this line equation where y is equal to mx, and in both the cases m is negative. In our both the equation m is negative. This is our second equation where m is negative, and this is our first equation where m is negative. ID is equal to minus m into VGS. Okay, so according to our concept, y is equal to m, VDS is on x-axis, so VDS is x plus, these are the fixed quantities which is not x or y anything here, so I'll call this as a c totally. So this equation is similar to y is equal to mx plus c, and m being negative, this will be the graph, or this will be the line equation. So plotting the similar line equation on this graph, I'll be having somewhat this type of line where this point and this point, so this point will be equal to c. Now what is c in our equation? In our equation, c is equal to VDD divided by RD plus RS. So here also it will be VDD divided by RD plus RS, which is a c point. Got this? This is a straight line given by our equation. Okay, one. Second, taking the first equation and our this graph where ID versus VGS, and our first equation was what it says, ID is equal to minus 1 upon RS into VGS, and this equation is similar to y is equal to mx only. There is no c. Y is equal to mx only. There is no other quantity which I can write it as a c. So y is equal to mx, and m is negative. Okay, so y is equal to mx. We had seen the graphs where it was showing again when negative, this is what the graph will be. Okay, y is equal to mx. This is what, from this point we have got this graph. Okay, so if I want to plot that graph, this graph will be in our characteristics passing through the origin somewhere touching here. Okay, this is our y is equal to mx graph, or ID is equal to minus 1 upon RS into VGS according to our equation. ID is equal to minus 1 upon RS into VGS. So two graphs we have got, this is one and this is the second. So these lines whatever we have plotted are called as a DC load lines. Those are called as a DC load line. So whenever anybody asks you what do you mean by load line, then you will have to tell all these things. What is DC load line? It is a load line or the line drawn on the characteristics, whether it is a transfer characteristics or whether it is a output characteristics, a line drawn, and this line depends on the C value and the slope, where slope is given by m. In our case, in both the cases I'll tell you what is m. In this case our m is equal to minus 1 upon RD plus RS, and for this line m is equal to, I'll show it here, m is equal to minus 1 upon RS. This is the slope. So here in the output characteristics m is equal to minus 1 upon RS. Okay, so I understood this concept. Y is equal to m is equal to minus 1 upon RS for transfer characteristics, and m is equal to 1 upon RD plus RS in the output characteristics. These are the two DC load lines we have drawn in transfer characteristics also and in output characteristics also. Okay, so why this line and why we have done it? Remember, these lines tell us, if, let us come here, this line tells us that whatever value you keep, or whatever RD plus RS value, or whatever VGS value you keep, or whatever VDS value you keep, if you have fixed VDD, RD and RS, these three quantities are fixed, then your ID value can be anywhere on this line only. Take any VDS, your ID value will be either from this point to this point only. There will be no other ID value. So we'll say from this circuit, this is what the circuit we have got. So from this circuit we can say, if VDD is fixed, RD is fixed, RS is fixed, because these are, once you make a circuit, these values will be fixed. VDD will be keeping something around 10 to 15 volts, whatever you want to keep it VDD, and RD and RS values are fixed. So we'll fix that, we'll do that, what to do. So once these values are fixed, then these lines are fixed. This line and also this line is fixed. So wherever this line, these lines are fixed, so that means, or that says we have operating point of this circuit, or called as a Q point, quiescent point. Operating point, Q point, quiescent point. That Q point, quiescent point will be lying on this line only. That's why it is called as a DC load line. Your Q point will be lying on this, or in the output characteristics on this line only. If you fix your VDD, RD and RS, so your Q point will be lying on this line only, whether here or whether here. Okay, so that is called as a concept of DC load line, which will be having a slope and a C cut, or intersection point C. So these 2 points are fixed. So what should we keep? The Q point, that is the operating point. What do you mean by Q point, operating point? Once VDD voltage is given, then this transistor will be operating. There will be some VGS, there will be some ID flowing, there will be some VDS voltage that will be going on, and how much that value will be? That value will be lying on this line only, where in this you can find VGS also, ID also, and VDS also. So if I keep VDS somewhere here, then this will be my ID. So I can say yes, by keeping VDS somewhere value, I'll get ID and VGS. Okay, so that's why we say that once the RD and RS and VDD are fixed, you will be getting a Q point, operating point, where transistor will be operating. Once the transistor is operating, then you can give AC signal and see the output voltage, amplified output voltage across a VO. Okay, so this is called as a DC load line concept. There may be a problems or the um, which will be asked during your examination, and what the problems will be, just like you are given a circuit, similar circuit I'll draw it again. This is what the circuit is. RD, RS and RG. This is the circuit which is having a gate, drain, source, and values are given. VDD is given say 15 volts, RD is given as 1K, RS is given say 500 ohms, RG is given say 1 mega ohm, and also two values are given. One is IDSS, which is equal to 4 milliamperes, and Vp is given, which is minus 4 volts. So if these quantities are given, then the problem will be find IDQ, VDSQ and VGSQ. Now what this Q is the point where the Q point is plotted. So that means finding out ID, VDS and VGS from this circuit. This may be the problem during your examination which will be asked. So how to solve this? Very simple way to do it. We are having the two equations. From that two equations will be three equations. From that three equations we'll find out what will be the value of ID, VDS and VGS for this circuit. So I'll show you how to solve that. So two equations are there. I'll make those two equations and then we'll go ahead. First equation, which was saying ID is equal to minus 1 upon RS into VGS. Okay, so this is what we have got. Putting this ID is equal to minus 1 upon RS into VGS. RS value we have got. RS is given here, which is equal to 500 ohms. VGS is not given, but taking this equation and putting in Shockley equation, which was saying ID is equal to IDSS into 1 minus VGS by VP whole bracket square. Putting that equation here, I'll be getting VGS value because I am having IDSS, I am having VP, and ID is given here, which is minus 1 upon RS into VGS. RS value is there. So RS is there, IDSS is there, VP is there. The only quantity which is unknown is now VGS. So putting in this equation, one unknown, so I'll be getting VGS value. But whatever VGS value you will be getting, that will be two values we will be getting because there is a square here. So two roots we will be getting. So let us solve this and find out what are the two roots you are getting.